In this video, I'll be answering questions on CLF3 and the two ions it forms when it self-ionizes. Questions 1 and 2 are to write a Lewis dot structure for CLF3 and draw the shape of this molecule. There are 4 things we need to think about when drawing a Lewis dot structure for any molecule. The first one is the amount of bonding electron pairs. The second one is the amount of lone pairs. The third is the charge on the molecule overall. And the fourth is whether or not the bonds within the molecule are double or single. In CLF3, there are 3 bonding electron pairs, 2 lone pairs of the central chlorine. The charge is neutral and it's made up of single bonds. Now, chlorine has 7 valence electrons, as does fluorine. And there are 3 fluorines to 1 chlorine in this molecule. Chlorine is a central atom, therefore chlorine will donate 3 of its valence electrons, 1 to each of the fluorines. This leaves chlorine with 4 electrons in its outer shell, and this is 2 lone pairs. Now this means that around the central chlorine atom there are 5 areas of electron density, or 5 bonded or lone pairs. Now this means that the electron geometry of the CLF3 is trigonal bipyramidal. This is a Lewis structure. Now, although the electron geometry is trigonal bipyramidal, 2 of these areas of electron density are due to lone pairs. Now, these lone pairs take up more space than the bonded pairs. This means that they want to be in an area where there are less electron groups. In this case, that would be the equatorial position, leading to the true shape of this CLF3 actually being a T-shaped, with the 2 lone pairs pushing the fluorines downwards. Now, question 3 is to sketch one other possible geometry and explain why it's not observed. As I said, it has a trigonal bipyramidal electron geometry. Therefore, there are 2 areas in which the lone pairs can occupy, either axial or equatorial. In the true shape, they are occupying the equatorial position. However, they could have chosen axial. In this case, a trigonal planar shape would be seen. But why didn't they choose axial? This is because 3D space is required by all electron pairs. The electron density and bonding pairs is between the 2 atoms within the bond, in this case in between the chlorine and the fluorine. Whereas in the lone pairs, the electron density is more close to the central atom. This means that they need slightly more space than these bonding pairs. The axial plane in a shape with 5 pairs is occupied by 4 separate entities. In this case, it's 3 fluorines and 1 lone pair, whereas the equatorial only contains 3. In this case, 2 lone pairs and 1 fluorine. Therefore, lone pairs will favour the equatorial position, where they have more space. If, however, they had chosen to occupy this axial plane, a trigonal planar shape would be seen. Question 4. What is the hybridization of the central Cl atom? Now, the atoms around the Cl are in 2 out of the 3 dimensions or planes. The top of the T is in the x-axis across the top, and the base fluorine is in the y-axis. Therefore, there are 2 out of 3 p subshells in use. This means the hybridization of the Cl is going to be sp2. Final question. Liquid CLF3 has a rather high electrical conductance. This is believed to be due to the self-ionization of the CLF3 to form CLF2+ and CLF4-. And we're going to draw the Lewis structures and name the expected shapes of each of these two ions. Here's our equation for the self-ionization of CLF3, and each of the two different ions produced have a different amount of lone and bonding pairs. So there are the same things that need to be thought about when drawing a Lewis structure and working out the shape. First one is the amount of bonding electron pairs in each one, followed by the number of lone pairs in each of the two ions, the charge on the ions, and whether they're double or single bonds. Now in this case, they both still have single bonds. Now overall, the bonding electron pairs in CLF2 is 2, one between the Cl and each of the two fluorines. In the second, CLF4-, there are 4 bonding electron pairs between the chlorine and each of the 4 fluorines. Now normally, 2 electrons bonded from a chlorine would mean that the chlorine has 5 electron pairs left. However, this is a positive ion. This means there's 1 less electron than normal, so the chlorine is left with 4 electrons, which is 2 lone pairs. Again, in the CLF4, usually with 4 electrons paired with another atom, the chlorine will be left with just 3 electrons. However, it is CLF4-, therefore it has 4 electrons left, and again there are 2 lone pairs. These are the Lewis structures for these 2 ions. As you can see in the square brackets, we've taken into account the charge of each of these 2. Now, to name the expected shapes of each of these ions, we've got to think about these things once more. Now, the total number of electron pairs in each of the 2 ions. Now, the first one, it has 2 bonding electron pairs and 2 lone pairs. It has 4 areas of electron density, or 4 electron pairs. The second one, it's got 4 bonding pairs, and it's got 2 lone pairs, so 6 areas of electron density, or 6 lone or bonded electron pairs. Now this means the CLF2 will have an electron geometry of tetrahedral, whereas a CLF4- will have an octahedral electron density, as there are 4 electron pairs in the first and 6 in the second. Now the CLF2 is going to take a bent shape. The 2 lone pairs are going to go to the top of the ion, and this is where they have the most space, and this means there will be more repulsion from one side, leading to a smaller bond angle of roughly 120 degrees between the 2 fluorines on the bottom. Now the CLF4, in this case, in both planes, the axial and the equatorial, there are 4 areas of electron density, 4 lone or bonded pairs. This means these 2 lone pairs of electrons are going to occupy the space further away from each other. In this case, on the top and the bottom,